Welcome back. In this video, I'll be looking at Pure Maths Year 2 Vectors Part 3. In Part 2 of the video, I went through 6 exam questions on Year 2 Vectors. Now I'm going to continue, starting off with question number 7. O to A is the vector 4i minus j minus 2k, and O to B is the vector minus 2i plus 3j plus k. Find Part A, the vector A to B, Part B, the distance between A and B, and Part C, the unit vector in the direction of the vector A to B. Let's start off with Part A, ladies and gents. First of all, we know that the vector A to B is given by O to B, take away O to A. O to B is minus 2y plus 3j plus k. Take away O to A, which is 4i minus j minus 2k. This gives us minus 2y plus 3j plus k minus 4i plus j plus 2k. Now we can simplify this by collecting i's, j's and k's. So if we do this, we end up with the following result. Minus 6i plus 4j plus 3k. So the vector A to B is minus 6i plus 4j plus 3k. Moving on to Part B. Find the distance between A and B. Well, the distance between A and B is given by the magnitude of the vector A to B. So the magnitude of the vector A to B. We know what the vector A to B is. It is minus 6i plus 4j plus 3k. We need to find the magnitude of this vector. It is given by square root minus 6 squared plus 4 squared plus 3 squared. So we can now put this into our calculator, and if we do this, we end up with square root 61 units. So the distance between A and B is just square root 61 units. Moving on to Part C. Find the unit vector in the direction of the vector A to B. The notation for the unit vector in the direction of the vector A to B is just the vector A to B with a little hat on top. This is given by the vector A to B itself divided by the magnitude of the vector A to B. We know what the vector A to B is. It is minus 6i plus 4j plus 3k. So we have minus 6i plus 4j plus 3k. We divide this by the magnitude of the vector A to B, which is square root 61. Therefore, the unit vector in the direction of the vector A to B is just this vector over here. That completes question number 7. Moving on to question number 8. For the given vector A, which is minus I plus 7j plus k, find the angle made by the vector with Part 1, the positive x-axis, Part 2, the positive y-axis, and Part 3, the positive z-axis. So let's start off with Part 1. Before I do anything, I'm going to first find the magnitude of the vector A because it's crucial in my next step. So the magnitude of the vector A, which is this vector over here, is given by square root minus 1 squared plus 7 squared plus 1 squared. So if I put this into my calculator, I get square root 51. Now I'm going to call theta x the angle between the vector A and the positive x-axis. First of all, I know that cos theta x is given by x over the magnitude of the vector A, where x is the coefficient of the vector I in the vector A. So what is the coefficient of the vector I in the vector A? It is minus 1. So I have minus 1 over the magnitude of the vector A. The magnitude of the vector A is square root 51. So I know that cos theta x is equal to minus 1 over square root 51. I can now calculate theta x. Theta x is given by cos inverse of minus 1 over square root 51. Right, I can put this into my calculator and round off my answer to, say, 2 decimal places. If I do this, I end up with the result 98.05 degrees. So 98.05 degrees is the angle that the vector A makes with the positive x-axis. Moving on to part 2. Now I'm going to call theta y the angle between the vector A and the positive y-axis. Okay, so I know that cos theta y is given by y over the magnitude of the vector A, where y is the coefficient of the vector j in the vector A. The coefficient of the vector j in the vector A is just 7. So I have 7 over the magnitude of the vector A, which is square root 51. So I know that cos theta y is equal to 7 over square root 51. Now I can calculate theta y. So theta y is just cos inverse of 7 over square root 51. Again, I'm going to round off my answer to 2 decimal places. So if I do that, I end up with 11.42 degrees to 2 decimal places. Okay, moving on to part 3. Now I want to work out the angle the vector A makes with the positive z-axis. I'm going to call this angle theta z. I know that cos theta z is given by z over the magnitude of the vector A, where z is the coefficient of the vector k in the vector A. So the coefficient of the vector k in the vector A is just 1. So I have 1 over the magnitude of the vector A, which is square root 51. So now I can go ahead and work out theta z. Theta z is therefore cos inverse of 1 over square root 51. So I'll put this into my calculator and I can round off to 2 decimal places. No problem, it's up to you. But in the exam, you should actually indicate what you round to in brackets. That would be quite useful. Okay, so if I round to 2 decimal places, I get 81.95 degrees. So the angle that the vector A makes with the positive x-axis is 98.05 degrees. The angle that the vector A makes with the positive y-axis is 11.42 degrees. And finally, the angle that the vector A makes with the positive z-axis is 81.95 degrees. Each of these angles are rounded off to 2 decimal places. And that there, ladies and gents, completes question number 8. Moving on to question number 9. The diagram shows the triangle PQR. Given that the vector P to Q is equal to 3i minus j plus 2k and the vector Q to R is equal to minus 2i plus 4j plus 3k. Show that the angle PQR is equal to 78.5 degrees to 1 decimal place. First of all, here is the angle PQR. We are after the angle PQR. Now, we can find the angle PQR if we know the lengths of each of these sides. So, first of all, I know what the vector P to Q is. I can calculate the magnitude of the vector P to Q in order to get the length PQ. In the same way, I can calculate the magnitude of the vector Q to R to get the length QR. So that is my first step. Let's start off with the magnitude of the vector P to Q. This is given by square root 3 squared plus minus 1 squared plus 2 squared. I can now put this into my calculator. So if I put this into my calculator, I end up with square root 14. Let's move on and work out the magnitude of the vector Q to R. So the magnitude of the vector Q to R is given by square root minus 2 squared plus 4 squared plus 3 squared. Now I put this into my calculator. So if I put this into my calculator, I end up with square root 29. So the length PQ is square root 14. The length QR is square root 29. I need to work out the length PR. First of all, I'm going to find the vector P to R. Now the vector P to R is given by P to Q plus Q to R. So we have the vector P to Q plus the vector Q to R. We know what the vector P to Q is. It is 3i minus j plus 2k. So 3i minus j plus 2k. plus the vector q to r, which is minus 2y plus 4j plus 3k. Now we can simplify this by collecting the I, j's and k's. So if I simplify this, I end up with I plus 3j plus 5k. So I plus 3j plus 5k. Okay, that's looking good so far. Now I can calculate the magnitude of the vector p to r. So the magnitude of the vector p to r is given by square root 1 squared plus 3 squared plus 5 squared. So now we can put this into our calculator. So if I put this into my calculator, I end up with square root 35. So square root 35 is the length p to r. I can label this length. So we have square root 35. Now we can work out the angle PQR using the cosine rule, okay? Because we are given 3 sides. So cos of the angle PQR is given by square root 14 squared plus square root 29 squared minus square root 35 squared all over 2 multiplied by square root 14 multiplied by square root 29. Okay, so we can actually simplify this by putting it into our calculator. So if we put this into our calculator, in the numerator I get 8, in the denominator I can keep it as 2 square root 14 square root 29. So we know what cos of the angle PQR is. It is this fraction over here. Now I can find the angle PQR by taking the cos inverse of this fraction. So if I do this, I get precisely angle PQR is equal to 78.5 degrees to 1 decimal place. Okay, so that there completes a question number 9. Let's move on to question number 10. A, B, C, and D are the points given over here, respectively. Part A, find the vector A to B and the vector D to C, giving your answer in the form Pi plus Qj plus Rk. Part B, show that the lines A, B, and DC are parallel, and that the vector D to C is equal to 2 multiplied by the vector A to B. Part C, hence, so you have to refer back to your answer in part B, describe the quadrilateral ABCD. So let's start off with part A. Now these coordinates are fixed from the origin, so we are looking at position vectors. So this point over here I can call it A, this point I can call it B, this point C, and this point D. So the position vector of the point A is just O to A. O to A is just 2 minus 5 minus 8. I've written the position vector as a column vector. I could have written it as ijk, but I'm going to keep it as a column vector for simplicity. Let's have a look at the position vector of the point B. That is O to B, which is equal to 1 minus 7 minus 3, and so on. So we have O to C, which is 0, 15 minus 10, and then O to D, which is 2, 19, and minus 20. Okay, so that's looking good so far. I've got my position vectors. Now I can go ahead and work out the vector A to B. The vector A to B is given by O to B minus O to A. So we have O to B minus O to A. O to B is 1 minus 7 minus 3 minus O to A, which is 2 minus 5 minus 8. So I can simplify these column vectors to give me my final result for A to B, which will be minus 1, minus 2, and 5. We need to rewrite this column vector in ijk form, okay? We need to write it in the form Pi plus Qj plus Rk. So in this case, it will be minus I minus 2j plus 5k. Okay, so in this particular case, for the vector A to B, P will be minus 1, Q will be minus 2, and R will be 5. Let's go ahead and work out the vector d to c now. So the vector d to c is given by O to c minus O to d. So O to c is 0, 15, minus 10. Take away O to d, which is 2, 19, minus 20. We can go ahead and simplify these column vectors. So if we simplify this, we end up with minus 2, minus 4, and 10, which is equivalent to minus 2y, minus 4j, plus 10k. So in this case, the p will be minus 2, the q will be minus 4, and the r will be 10. So I found a to b and I found d to c in the form pi plus qj plus rk. Moving on to part b. Show that the lines AB and DC are parallel and that d to c is equal to lots of a to b. So d to c is just the vector minus 2y minus 4j plus 10k. But this vector over here is just two lots. I repeat, two lots of the vector minus I minus 2j plus 5k. That vector over there is just the vector a to b. So we have two lots of the vector a to b. Hence, the lines AB and DC are parallel because DC is a scalar multiple of AB, and we have that D to C is equal to two lots of A to B as required. Moving on to part C. Hence, describe the quadrilateral ABCD. Now we have that DC and AB are unequal parallel sides. So we can write DC and AB are unequal parallel sides. A trapezium has unequal parallel sides, hence we can conclude that the quadrilateral ABCD is a trapezium. And that there completes part C of the question and the question number 10. Moving on to question number 11. Given that 3i plus p plus 2 in brackets j plus 120k is equal to pi plus qj plus 4pqrk, find the values of pq and r. Now we can find the values of p, q and r by comparing the coefficients for I, the coefficients for j and the coefficients for k. So if I compare the coefficients for I have that 3 is equal to p, or you could say p is equal to 3. Comparing the coefficients for j, we have that p plus 2 is equal to q, but p is 3. 3 plus 2 is equal to q, hence q is equal to 5. Comparing the coefficients for k, 120 is equal to 4pqr. But I know what p is, it is 3. I know what q is, it is 5. So if I put p equal 3 into here, q equal 5 into here, I get 120 is equal to 60r. Now I can solve for r to give me r is equal to 2. So p is equal to 3, q is equal to 5, r is equal to 2. Moving on to the last question, which is question number 12. A particle of mass 2 kg is in static equilibrium and is acted upon by 3 forces. So we have F1, F2 and F3. Part A, find the values of the constants A and B. F2 is removed. Work out part B, the resultant force R. Part C, the acceleration of the particle, giving your answer in the form pi plus qj plus rk meters per second. Part D, the magnitude of this acceleration. And part E, the angle the acceleration vector makes with the unit vector j. Right, let's start off with part A. Firstly, there is a key word, static equilibrium. This implies that the particle is not moving, that is, the resultant force acting on the particle is equal to 0. So for part A, I can start off by writing that the resultant force on the particle is equal to 0. Now the 0 vector in 3 dimension, you can write it as a column vector 0, 0, 0. The resultant force R is the sum of these individual forces. So this implies that F1 plus F2 plus F3 is equal to 0, 0, 0. F1 as a column vector is 1, minus 1, minus 2. F2 as a column vector is minus 1, 3 and B. And F3 as a column vector is 0, A and minus 2. This must equal 0, 0, 0. Now I can simplify these column vectors by adding them together. So if I do this, I get 1 plus minus 1 is 0 plus 0 is 0. Minus 1 plus 3 is 2 plus A is 2 plus A. Minus 2 plus B is minus 2 plus B. Plus minus 2, that will be minus 4 plus B. This has to equal 0, 0, 0. Now if I compare the J and the K, I can generate two equations. The first one will be 2 plus A, which is equal to 0. The second one will be minus 4 plus B, which is equal to 0. Now I can solve for A and B. So A equal to 4. Okay, so that there completes part A. Moving on to part B. F2 is removed, work out the resultant force R. So if F2 is removed, the resultant force R is a sum of the force F1 and F3. So the force F1 is just 1 minus 1 minus 2, and the force F3 will be 0, my A value which is minus 2, and we have minus 2. So now I can work out the resultant force R. 1 plus 0 is 1. Minus 1 plus minus 2 is minus 3. Minus 2 plus minus 2 is minus 4. So that there is the resultant force R. I can put N at the end, newtons. I can rewrite this in IJK form. It will be I minus 3J minus 4K, in brackets, newtons. So that there completes part B. Moving on to part C. Okay, for part C, we want the acceleration of the particle, giving your answer in the form pi plus qj plus rk meters per second per second. Okay, so for part C, we can start off with Newton's second law. And Newton's second law states that the force F is given by mass multiplied by the acceleration A. Now the force F just represents the resultant force. In this particular case, the resultant force R is 1 minus 3 minus 4. So we have that I minus 3J minus 4K has to equal the mass. We are given the mass, it is 2 kg. So 2 multiplied by the acceleration vector A, which we are after. So now the acceleration vector A is given by I minus 3J minus 4K all over 2. You can simplify further to give you a half I minus 3 over 2 J minus 2K, in brackets, meters per second. So that there is the acceleration vector in the form pi plus qj plus rk. That completes part C. Moving on to part D. Now for part D, we want the magnitude of the acceleration vector. So the magnitude of the acceleration vector, which is this vector over here. So you would find the square root of a half squared plus minus 3 over 2 squared plus minus 2 squared. So now, ladies and gents, we can put this into our calculator and find the magnitude of the acceleration. So in exact form, this will be square root 26 over 2 meters per second per second. So that there is the magnitude of the acceleration vector. Moving on to part E. Now for part E, we want to work out the angle the acceleration vector makes with the unit vector j. So the acceleration vector A is this vector over here, a half I minus 3 over 2j minus 2k. We want to work out the angle that this vector makes with the unit vector j. In other words, we want to work out the angle this vector makes with the y-axis, okay? With the y-axis. Remember, this vector is in 3 dimensions. So first of all, I can calculate the magnitude of the vector A, which I've already done in part D. This is square root 26 over 2. Now I can call theta y the angle between the acceleration vector A and the y-axis, or you could say the unit vector j. So we have theta y. We want to work out theta y. Well, first of all, we can calculate cos theta y. Now cos theta y is given by y over the magnitude of the acceleration vector A. Y is just the coefficient of j in the vector A, which is the acceleration vector. So the coefficient of j is minus 3 over 2. So we have that cos theta y is equal to minus 3 over 2 divided by square root 26 over 2. Now we can take cos inverse of this fraction to give us theta y. So if I do this, I get theta y is equal to, so cos inverse of this fraction over here, it will be 126 degrees. Okay, to the nearest whole number. Remember, you should put in brackets what you round to. In this case, nearest whole number. So the angle that the acceleration vector makes with the unit vector j, in other words, the angle that the vector makes with the y-axis is just 126 degrees. Now, if you found this video useful, please don't forget to subscribe.